Welcome, Mr. Anderson here. Let's review a little bit about polynomials. Classify the following polynomial by degree and then number of terms. So the degree of this is 3. It's the highest exponent in the polynomial, and we call that a cubic. It is just a number, like a 7. We call that's just a constant. Oops, constant. All right, and so if we have just like x, that is a linear polynomial, and x squared, that would be a quadratic. X squared is a quadratic. Third power, that's cubic. Fourth power, that would be a quartic. Fifth power, quintic. And then above that, we would just say sixth degree polynomial. Okay, so that is the degree. And then we would say the number of terms. So this has 2 terms, and it is called a binomial. If there's just 1 term, we call that a monomial. So 1 term, monomial. 2 terms, binomial. 3 terms, trinomial. And then after that, we would just say a polynomial with 4 terms, 5 terms, 6 terms, whatever we have. So if we have a quintic with 5 terms, we say a quintic polynomial with 5 terms or 4 terms. Second question, multiply the following 2 polynomial factors and simplify. Write your answer in standard form, of course. So here we are just distributing. We need to distribute this x with all 3 terms in the other factor, and then we need to distribute the 3 with all 3 terms in the other factor. So let's distribute that x. X times x squared is x cubed. X times 2x gives us 2x squared. And x times negative 15, negative 15x. Then we have to distribute the 3, so 3 times x squared is 3x squared. Notice I put that right underneath the other x squared term because I know that I'm going to be combining like terms. 3 times 2x, that gives us a positive 6x, and 3 times negative 15, negative 45. Now we are ready to combine any like terms. Like terms are those with the same variable and same exponents. Nothing to combine the x cubed with, so we just write that down. We got 2x squared plus 3x squared gives us 5x squared. And we got negative 15x plus 6x, that gives us minus 9x. And then nothing to combine the constant by, so we have minus 45. X cubed plus 5x squared minus 9x minus 45. That's what we get when we multiply that binomial with that trinomial. Number 3, use synthetic division to simplify this polynomial. Write your answer in standard form. Okay, so we have this binomial factor down here that we are dividing by, I should say divisor. We have a binomial divisor. And we are dividing this cubic by that. This is synthetic division. I start with this elongated L. Right? And then on the outside of this L, I'm going to put a positive 3. And that comes from this right here, this divisor, that minus 3 right down there. Notice I put down a positive 3, not a minus 3. Because what we write on the outside there is actually 0. Right? The x minus 3 equals 0. And add 3 to each side makes the x equals 3. And that's really where the 3 comes from. On the inside, we are just writing all the coefficients of the polynomial we are dividing. So we have a 4 of the x cubed. We have negative 15 of the x squared. Now, if we were missing like x squared terms, they weren't even written there, we would have to have that placeholder here, and we'd have to write 0 of the x squareds. Right, but no, we got negative 15x squared, so we write that coefficient down, and we got 14, and then the constant is negative 15. Synthetic division, we follow this pattern. We add down and multiply up. So this is what that means. When we add down, I add those coefficients. I add that first coefficient, 4, and I don't have anything to add it to. 4 times nothing is, 4 plus nothing is 4. And that's what you're always going to start off with, is adding down. So in effect, you're just going to be carrying down that lead coefficient down below the line. So when we add down, we are putting the number down below the line. Add down, multiply up, and we just keep following this pattern. Add down, multiply up. When we say multiply up, I'm going to be putting a number in the next column above the line. And we are always multiplying by this 0 that we wrote on the outside, this 3. We multiply with that 3. 3 times 4 is 12, and that gets written above the line in the next column. And we continue that pattern. Add down, so negative 15 plus 12 is negative 3. Multiply up. We take that 3, always multiplying by that 3 up there, times negative 3, and we multiply up, so that goes up to the next column above the line. 3 times negative 3 is negative 9. 14 minus 9 is 5 because we added down. Multiply up. 3 times 5 is 15. And finally, we add down. We always end with adding down. We always start and end with adding down in synthetic division. Negative 15 plus 15 is 0. And I like to put a box around this last number here below the line. This is your remainder. When you're dividing this cubic right here by this x minus 3, we ended up with a remainder of 0. And here is the polynomial that we end up with when we divide those two. That's the quotient. And this is how it's read. So this first number here in the box, going back from right to left, this first number is the remainder. We have no remainder. Then this is the constant term. Then the negative 3 is the x term. And the 4 here is the x squared term. Notice when we started out, we had coefficients. This was the x cubed. When we divided out the x, we end up with an x squared because we divided out one of those x's. Down at the bottom, that becomes the x squared column. And same here, the negative 15 was the x squared. We divided out an x, and that becomes just an x. So we have negative 3x. So this is read 4x squared minus 3x plus 5. And there's no remainder, so there's no reason to write a remainder here. When you divide 4x cubed minus 15x squared plus 14x minus 15. When you divide that by x minus 3, this is what you get. You get this quadratic trinomial. So if you were to multiply x minus 3 times this quadratic trinomial, you would get this cubic that is in the numerator. 4x cubed, etc., etc. Let's move on, and we have some more synthetic division here. Question number 4 says, use synthetic division to evaluate the following polynomial function for the specified value. So it says f of x equals x cubed minus 5x squared plus 4x minus 20, and we need to find f of 6. That means we need to plug in 6 where all the x's are. It is just substitution. But instead of doing that, we are going to use synthetic division. So I'm going to start with that elongated L again. When you use synthetic division to substitute, to plug in some sort of specific value, on the outside, you're going to put the number that you're substituting in. Right? Don't write -6 here. We're going to write that actual number that we are plugging in. Very important to remember that. When we're dividing polynomials, right, we wrote the 0 on the outside, and in effect, it looked like we were writing the opposite of the number in the divisor. Here, plug the exact number that you're plugging in. Write that on the outside. The inside, exact same thing. Write down the coefficients. We have 1 of the x cubes. We have -5 of the x squareds. We have 4 of the x's, and -20 is our constant. And you know the deal. Add down, multiply up, always multiplying by this number outside. 6 times 1 is 6. Add down. -5 plus 6 makes 1 again. 6 times 1 equals 6, multiplying up. And add down. 4 plus 6 is 10. Multiply up again. 6 times 10 is 60. And finally, we always start and end with adding down. We have -20 plus 60 is 40. And I'll put a box around that. This remainder number here is the only number that I'm interested in. And it says 40. If I plug in 6 in place of x in that function, I will end up with 40. So the answer for what is f of 6? The answer is 40. Right? I'm not interested in that 1, and that other 10. Just the very last number. When you use that synthetic division to substitute. Next question. How many zeros or roots does the following polynomial have? Easy enough. The degree of this polynomial is 5. It's a quintic polynomial. With 4 terms, and so it has 5 zeros. The number of zeros that a polynomial has is the exact same as the degree. And then we get to the next question: how many linear factors does the polynomial have? And same thing. It is a degree 4 here. It's a quartic, and we have 4 linear factors. So a polynomial has the same number of zeros as the degree, and the polynomial has the same number of factors as the degree. All right, although zeros and factors are not the same thing, let's make sure and keep those two straight, and we'll look at that in a little bit here as well. Okay. Number 7, factor the following sum of cubes and difference of cubes using the formulas. Okay, so a sum of cubes. Sum, of course, is adding, and we are adding a perfect cube and a perfect cube. All right, what makes a perfect cube? Like 27 is a perfect cube because 3 times 3 times 3 is 27. Right, 8 is a perfect cube because 2 times 2 times 2 is 8. 1 is a perfect cube because 1 times 1 times 1 is 1. And 64 is a perfect cube because 4 times 4 times 4 is 64. 125 is a perfect cube. So 5 times 5 times 5 is 125. 216 is a perfect cube. 6 times 6 times 6. So this here is a perfect cube, and this over here, the 125x cubed is a perfect cube, and 64 is a perfect cube. Right? X cubed is a perfect cube because x times x times x is x cubed. Right? Y cubed would be a perfect cube. So 125x cubed is a perfect cube, and 64 is a perfect cube. In order to find the a and the b, you need to take the cubed root of each of those terms. Okay, so the cubed root of 125x cubed is 5x, because the cubed root of 125 is 5. The cubed root of x cubed is x. So the cubed root of 125x cubed is 5x. This is a sum of cubes, and so we are going to follow this pattern. The cubed root of 64, that's 4. 4 times 4 times 4 is 64. So I'm going to use this formula over here for a sum of cubes. All right, we got a sum here, so I'm going to use a sum of cubes. All right, we got a sum of cubes here. Over here on the other end, we have a difference of cubes, because it's subtraction, right? And I'll use this formula over here for a difference of cubes, right? They're both the exact same formula. The only difference is the signs in between the terms. And by the way, we use the term, the acronym SOAP to remember these signs. So in a difference of, a sum of cubes, we start off with the same sign as what we started with, like 125x cubed plus 64. I started off with a plus, and I'm factoring this sum of cubes. Now let me write the 64. And so we use the same sign as what we started off with. That's what the S of SOAP stands for, same sign. Right? And then we move over to our trinomial factor, and the O of SOAP stands for the opposite sign. And then the last sign, the AP of SOAP, stands for always positive. So we can keep the signs straight in these two formulas. Notice a difference of squares. We start off with negative, so we keep the same sign, S of SOAP. And then the next sign, opposite, the O of SOAP. The opposite of the negative, the minus there, so that's plus. And then the last sign is always positive. All right? These two formulas are exactly the same except for the signs. And so what I like to do is we have AB in the first binomial factor, and I'll write down the cubed root of the first term right here. I mean, you have to, that's what A is, the cubed root of the first term, 5x, and you write down the cubed root of the second term, where the B is. And so now I have the A and the B here, and I just think it through. And okay, now I'm ready for my trinomial factor. And what do I have to do? I got to do a squared, so that's 5x times 5x. Let me just write that down here. 5x squared. A is 5x. A equals 5x, right? So a squared. So a squared is 5x squared. That means 5x times 5x, which is 5 times 5 is 25, and x times x is x squared. All right, so I just took that a term, that first term in that binomial factor, and I square it. In the middle, easy enough, I multiply a and b. So that's 5 times x times 4. That is 20x. And then the last term in the trinomial factor, b squared. I got to take this 4 and square it. Right? 4 squared is 4 times 4. And so I'm not going to write 4 squared. I'll write what that is. It's 16. And you think about it, these formulas are actually kind of easy to remember, right? You know that when you have a sum or difference of perfect cubes, you know you need this a and b, right? And that's what's going in the first binomial factor. And if it's sum of cubes, you got plus. If not, you got if it's difference, you got a minus. All right, so you write down the a, b, and this trinomial. What are you doing here? You take the a and you square it. This last term, that's the b, and you square it. And in the middle, it's like the combination. I multiply the a and the b. All right, so it's like this is a times a, this is a times b, and this is b times b. All right, it seems to logically follow. Let's go to this difference of squares. Okay, we need the a. So the cubed root of x cubed is x, because x times x times x is x cubed. The cubed root of 8y cubed is 2y, because 2 times 2 times 2 is 8, and y times y is y cubed. Move on to our trinomial. I've got to square a, which is our first term over here. So that's just x squared. X times x is x squared. The middle term is a times b, so I got to multiply these two terms. X times 2y gives us 2xy. Last term's always positive, and I have to square b. That's 2y squared. 2y squared. That means 2y times 2y. It gives us 4y squared. And that's our answers. Right? Pretty easy formula to plug into. Maybe getting a little bit used to it. Question number 8. Choose the correct end behavior for the following polynomial function. And we have 88x to the 14th power plus 123. This is a 14th degree binomial polynomial. 14th degree polynomial with a binomial. Oh, that's hard to say. Okay. The end behavior is what happens at the ends of the graph. So let's take a look at this. Y equals x squared. What happens at the end of that graph? We know that looks like a parabola. And at the end, it goes up on the left end, and it goes up on the right end. Let's take a look at y equals negative x squared. That we know that the parabola is just going to open downwards instead. And we know on the left end, it's going down to negative infinity. It's going down. On the right end, also, it is going down. Let's think about some other functions here. Y equals x cubed. Looks something like this. Well, these are not straight lines. Here, I'll exaggerate it a little bit. Okay. All right, so as we're going to the left here, on the left end of this graph goes down to negative infinity. And as we're going to the right, goes up to positive infinity. All right, that's y equals x cubed. If we had the negative of this, if we had y equals negative x cubed, it's going to be the opposite. We start up at positive infinity, and then it goes down to negative infinity on the right side. So on the left side of the graph, now we start up, and on the right side of the graph, we go down. right? And end behavior, these are the only four things that can happen with end behavior. And so all even degree polynomials follow these two end behaviors. And all odd degree polynomials follow these two end behaviors. Right, notice that this y equals x squared, it was positive. It had a positive coefficient, because we know if we put a negative, that's what flips the graph upside down. We put a negative in front of that lead term. All right, so this was positive, and this was negative. Same with these cubics that I wrote over here. This was positive, and if it was negative, we'd flip that upside down, giving it the opposite end behavior. So all even degree polynomials that have a positive coefficient, they are going to have this same end behavior, up and up. And that's the common way to say it. You read it from left to right, and people know what you're talking about. You say if the end behavior is up and up, they know you're talking about the left end and then the right end. Right? And an even degree polynomial with a negative coefficient, the number in front of the variable, right? If that's negative, then we have down and down. Down the left, down the right. All odd degree polynomials, then we're over here on this side. Odd degree polynomials with a positive coefficient, they all have this end behavior, down and then up. All negative odd degree, right? Negative coefficient, odd degree polynomials do this. On the left side, they go up to positive infinity. Right side, they go down to negative infinity. So let's read how this is read over here. These arrows are read as approaches. So we read this, it says, as x approaches negative infinity. As x approaches negative infinity, think about our graph. Right, here's our x-axis, and here's our y, or you could say f of x, right? Y f of x, it's the same thing. Okay, so as x approaches negative infinity, we are going to the left, right? The numbers are getting smaller and smaller and smaller, all the way to negative infinity. So this is saying, as we are going to the left on our graph, f of x, or y, is going towards positive infinity. It is going up. So which one does this match? As on the left end of the graph, it's saying we are going up, just like this right here. Okay, and as we go to the right, as x approaches positive infinity, right now we're going the other way. We're going to the right. So the numbers get bigger and bigger and bigger, all the way to positive infinity. So, and as x goes to positive infinity, as x goes to the right, f of x, or y, also goes to positive infinity. It is going up, right? That's the direction our numbers get bigger and bigger. So it is just like this first one here. As on the left end, we are going up forever, and the right end, we're going up forever. This is up and up. Okay, and notice each one of these on the left side, it says as x approaches negative infinity. All of these are going to the left. It's saying, okay, what's happening as we go to the left end of the graph? So this one says, as we're going to the left, y is going to negative infinity. So that's going down. As we're going to the left, y is going to negative infinity again, so that's down. As we're going to the left, y is going up, right, to positive infinity. And let's look at these. All of these are saying as x is going to the right, saying what happens on the right end of the graph. As x going to the right, positive infinity, y is going down, your negative infinity. Here it's saying y is going up to positive infinity, and here it's saying y is going down, negative infinity. So you can see this first one says up, and that's what we have here because we have a positive coefficient and we have an even degree polynomial. Positive coefficient, even degree, right? It's up and up, right? Left, up, right, up. B would be like a negative even degree, down and down, right? C is like a positive odd degree, down and up, just like this one over here. And then the last one is like a negative odd degree, up and down. So all even degree, that's the exponent. Don't mix up the degree and the coefficient. Even degree positive polynomials do the same thing. They go up and up at the end. So x squared, x to the 4, x to the 8, x to the 12, x to the 14, like we go here, right? Those all, the positive coefficient goes up and up. If it was a negative, it goes down and down. Number 9 says, identify the real zeros for the following graph polynomial function, then circle whether the zero has an even or odd multiplicity, and circle the effect that zero has on the graph. All right, so zeros are the same things as x-intercepts. They're the same thing as x-intercepts. And I look at this, and I see, oh yeah, I got two x-intercepts here. One's at negative 1.5, or you could say negative 3/2, and one is at 2. That's where it crosses the x-axis. Those are my two zeros, my two real zeros. I see those. And it asks, what's the multiplicity and the effect on the graph? Okay, so when your graph just touches the x-axis and bounces off, right? It's going towards the x-axis, but it doesn't cross over. It bounces off the x-axis. Then you have an even multiplicity. You have an even multiplicity. So when it bounces off the graph, you have an even multiplicity. As opposed to over here, where the x equals 2, we have a 0 of 2. The graph is going to towards the x-axis, and it just goes straight across, right at 2. All right, that means we're going to have an odd multiplicity when the graph just crosses over the x-axis. So even multiplicity, just how many times is this 0 repeated? Right, it could be, so it's repeated a minimum of 2 times. It repeated a minimum of 2 times. And it could be repeated 4 times, 6 times, 8 times. So I know there's at least 2 factors that are in whatever this polynomial, I know there's at least 2 factors that are, let's see, that's negative 3/2, and the factor for that 0 would be 2x plus 3. I know there's at least 2 of those factors that are 2x plus 3. And for this 0 down here, it's an odd multiplicity. So I know it repeats, it starts at 1, right? It repeats once, I guess. It could be just by itself. 1. I could have that just once. And the 0 for that would, the factor for that would be x minus 2. Okay. It could repeat 3 times, and I'd have x minus 2, x minus 2, x minus 2 as factors. It could repeat 5 times, 7 times. So the zeros here I know that this function has these zeros. Right? Negative 3 halves. And I see it right there, crossing over at negative 3 halves. I know that it has, there's another negative 3 halves. And 2. Okay? Zeros, x-intercept, same thing. I see the 0, x-intercept. And the important thing is, I see this 0 here. Let's take the 0 of 2. Hey, I know the factor then. If the 0 is 2, I know that the factor is x minus 2. Right? Remember how we find zeros from factors? We set that factor equal to 0. 2x plus 3. We set that factor equal to 0. We solve for x. So subtract 3 from each side. We got 2x equals negative 3. And divide by 2 on each side. Oh, let's write that 2 too fast. And so the 0 for this factor would be negative 3 halves. Right, which we see on the graph. That is the 0. That's the negative 3 halves, the negative 1.5 that we see here. Right, so the 0 of this 2x plus 3 is negative 3 halves. And we already know that. We see it bounce off the graph right at negative 3 halves. Right, same for this one, right? And you don't have to set them equal to 0. You just think about it. It's the same two-step equation over and over again. I'm going to move the 3 over to the other side, so I got to subtract 3 from each side, and then I got to divide by 2, giving me the opposite of this second term, and negative 3, and divided by 2, and that's the 0. Here I don't have a number in front of the x, so it's just the opposite of the 2. I'm just moving like the 2 to the other side of the equal sign. Next question, number 10. Factor the above polynomial that is graphed to the right. Well, one thing I noticed right off the bat is, hey, I have a 0. I have a real 0 there at x equals negative 6. That means that one of the factors for this polynomial is x plus 6. Okay, so I've got this function, x cubed plus 6x squared plus 4x plus 24. And if I divide this cubic function by x plus 6, that is going to lower this polynomial by 1 degree. Right? And I'm going to use synthetic division to do that. I know this factor exists, and so I divide it out of this polynomial to make it something easier to factor. Synthetic division again. I have negative 6. Write down the coefficients. 1, 6 of the x squares, 4 of the x's, 24 is our constant. Add down, multiply up. Negative 6 times 1 is negative 6. Add down, we have 0. Negative 6 times 0 is 0. Add down, that's 4. Negative 6 times 4 is negative 24, and we end up with a remainder of 0, which we should end up with because we know that x plus 6 is a factor because we see that x-intercept at negative 6. So this reads, there's a remainder, 0. This is our constant term, this is our x squared. This is our x term, and this is our x squared term. No x's. So we have x squared plus 4. When I divide out x plus 6 from this cubic polynomial, I end up with x squared plus 4. If I was to multiply x plus 6 times x squared plus 4, I would get that original x cubed plus 6x squared plus 4x plus 24. Right, I want to factor this completely, though, so I want to break this x squared plus 4 apart. Okay, so what are the factors for this x squared plus 4? Set your x squared plus 4 equal to 0. Like, find the zeros of this x squared plus 4. just like we know that x plus 6, the zeros for this, I'll write it down. The zeros for this is negative 6. That's the 0. Right? And we get that by setting that factor equal to 0. So let's set this factor equal to 0 and see what the roots are for this particular factor. Subtract 4 from each side of the equation. And we have x squared equals negative 4. And to get rid of the x squared, I am going to take the square root of each side. Whenever you apply a square root, do not forget to do the plus and the minus. Apply the positive and the negative of it. So the square root gets rid of the square, and I have x equals plus or minus. I have this negative under the square root. That is where our imaginary numbers comes from. I is equal to the square root of negative 1. And underneath this square root, I have negative 1 times 4. Right? Negative 1 times 4, that's negative 4. That's what I have here. So whenever you see a negative underneath the square root, you can just take that guy right out and you can call it I. I'm just taking that negative 1 out and calling it I, because that is what I is defined as. I equals the square root of negative 1. So that's how we handle the problem with the negative under the square root. And we know that the square root of 4 is 2. All right, so my two roots for this x squared plus 4 factor are positive 2i and negative 2i. Positive 2i and negative 2i. All right, I didn't have to write the positive there. So think about what are the factors. Like the factor with the negative 6, we know that's x plus 6. Right, so the factor associated with this positive 2i, that's x minus 2i. Right, the factor associated with this negative 2i would be x plus 2i. Right, and I have factored this completely. Right, 3 roots, negative 6, positive 2i, negative 2i, 3 roots. Degree of 3, we know there has to be 3 roots. Here's the roots. We also know there has to be 3 factors. If I multiply x plus 6 times x minus 2i times x plus 2i together, I would get this original function of x cubed plus 6x squared plus 4x plus 24. All right, so I have factored this completely. Take a look at the big idea here. I'm given this function, x cubed plus 6x squared plus 4x plus 24. I'm given this cubic function. I need to factor it and say, that's kind of difficult. The easiest thing to do would be, hey, graph it and find the real factors to divide out. So I graph it. I see, oh, it crosses over at negative 6. I know one of the factors is x plus 6 then. Right? Graph it. Find real factors and divide them out. That drops down this polynomial from a cubic to a quadratic, which is easy to factor. Right? Quadratics are easy to factor. It makes this problem a lot easier. Like, oh, good, it crosses the x-axis. I can divide something out and make this quadratic. That moves down to quadratic, and then factor that quadratic. Plug it into the quadratic formula. Here we applied square roots. Last question. Factor the following polynomial completely by grouping. Okay, and this is a prime target for grouping. I'm going to group the first 2 terms together, 5x squared. And I am going to group the last 2 terms together. And so the idea on this grouping is I'm going to factor out a GCF from both of these groups, and I want the same thing, the same binomial to be left in these groups. I can factor out an x squared from this first group, this first binomial, right? I can factor out an x squared. Factoring out means dividing out. When I divide out x squared here, I'm left with an x. I divide out an x squared from the 5x squared, I'm just left with 5. You can always redistribute, and make sure that you did it right. X squared times x is x cubed. X squared times 5 is 5x squared. I want to do the same thing over in the second grouping. In the first place, you always want to factor out a negative out of a lead term. They both have a negative 4 in common. They can both be divided by negative 4. When I divide out negative 4, I am left with x plus 5 again. And this is what is key. Right? I end up with the same binomial in both my groupings once I factor something out. So my two factors from this are x squared minus 4 and x plus 5. And you say, well, wait a minute, how come you can do that all of a sudden? Right? Think about FOIL, this sidebar story. You think if we were multiplying x, let's make it something simple, x plus 2 times x plus 3. Right? The F and the O of FOIL distributing that x, that'd be x squared. Oh, let's do it this way. X times x, and then x times 3. And then I'd have to add to that distributing the 2 with the x and the 3. So that'd be x, or 2 times the x and 2 times the 3. Notice what I have here. This is how I distribute it. X times x and x times the plus 3. That's this over here. 2 times the x and 2 times the plus 3. Because I have both the same binomial group here, right? And I factored out a number. This is what I started with. We are doing FOIL in reverse. Right, here's where the 2 came from. Here's where the x came from. And the x plus 3 came from that same factor that I was distributing. That's why we can do this. Here's the x plus 5. The negative 4 comes from that. And the x squared comes from that. Right? X squared times x plus 5. Right? If I was going to remultiply this, it would be x squared. I got to distribute with the x and the plus 5. X squared times x plus 5. That's what this is. X squared times x plus 5. And then I'd have to continue on distributing the negative 4. That'd be negative 4 times x and negative 4 times plus 5. That's what this part is over here. Okay, so I factored by grouping. I grouped the first 2 terms and grouped the last 2 terms. And the key is I want to factor something out from both of those groupings. I want to factor out a GCF so that what is left is the exact same binomial, the exact same grouping, right? And that goes as one of the factors. And then whatever my GCFs are, that's the other factor. Now this can be continued, right? Because not factored completely yet, because I can factor this x squared minus 4, and you might remember that as a difference of squares. Difference of squares. You have the square root of the first term, square root of the second term. Whoops, I wrote a 4, not a 2. X squared plus 2, x squared minus 2, and it looks like a 1 now. X squared plus 2, x squared minus 2. I just cannot get this straight. X plus 2, x minus 2. And that is your difference of squares. And I found all 3 factors. If I multiply x plus 2 times x minus 2 times x plus 5, I will end up with this cubic polynomial with 4 terms at the very beginning. All right, this is completed. This is factored completely. All right, there ends our review, and I hope this was helpful, and I will see you on the flip side.